Unit 2 is called Basic Angle and Segment Relationships. Lesson 2.1 starts with just segment addition postulate. So we're just going to learn what happens when we have segments with different lengths and how we can use algebra to solve some missing lengths. So number 1, it says look at the diagram and evaluate which of the statements below is true. Sometimes they'll switch this up and say which is false, but which is true. So we've got all these different points here on a number line. It says that RT, that distance, is less than RS. Well, R to T, R is at 12, T is at 19, so think that's a distance of 7. And then R to S is from 12 to 18, which is 6. Is 7 less than 6? No, so that's false. That QR, that distance, equals RS. Q to R is 6, and R to S is also 6. That is true. So you would just keep going until you find it. This one says that QS is greater than QT, which you can also see that's not true, and S is the midpoint of RT. You can see S is definitely not in the middle of R to T. All right, then we talk about this thing. It's called segment addition postulate. A postulate is just a fancy word for a rule, something that always happens, and it's adding parts of segments. So what this shows in this picture is that AB, which is a distance from point A to B, plus B to C, that distance, would equal the total A to C. Let's just say that this was 3 and this was 7. I could add 3 plus 7, and that would tell me that this entire distance is 10. It's a very simple rule. So we're going to use that for these next problems. It says point K is on the line segment JL, and I like to draw a picture. So I'm going to put J is one endpoint, and L is the other endpoint. K is somewhere in here. It doesn't matter where you put it. K to L is a distance of 7. J to K is a distance of 9. Figure out the length of J to L. So you're just adding this together to tell you that that is 16. So whenever they're wanting a length, you don't have to put the line segment symbol over it, but you can. All right, number 3. Point D is on line segment CE. So I'm going to draw another segment here. Endpoint C, endpoint E. D is somewhere inside of here. CE is 17. So be aware that they're telling you the total distance from one endpoint to the other. D to E is 7. Find the length of CD. So this time you would have to subtract. You would have 17, take away the 7, and get that this part is really 10, because 10 plus 7 makes 17. Pretty simple. And then number 4, uses some algebra. Point J is on line segment IK. JK is 2x minus 1. I to K is 3x plus 2. And I to J is 3x minus 5. Determine the numerical length of JK. So not only do we want to solve for x, we're going to have to plug it back in to get how long JK actually is. Okay, so what we need to know is that segment addition postulate really just says a part plus the other part equals the whole. So I'm going to set it up to where this 3x minus 5 plus the other part, 2x minus 1, equals the whole thing of 3x plus 2. To solve, I want to put my like terms together on each side. So on this side, I have my 3x plus 2x. That gets me 5x. Then I have my constants, my negative 5 and negative 1 makes negative 6. Then I want to get my like terms together on opposite sides, so that's doing the opposite thing. I'm going to get my x's together first, which is what I always recommend. And I always move the smaller x value just because that will keep my x's positive. So I'm going to subtract 3x since that's a positive 3x. That would get me 2x, bring down my minus 6 equals 2. From there, I'm just solving. So to get x by itself, I want to add 6. Bring down my 2x. So 2 times the number is 8. You should already know that that makes 4, but to show it with work, you divide by 2 to make that 2 cancel. 8 divided by 2 is 4. Now we're not done. It wants the length. The length is not 4. That's what needs to be plugged in for x. And so if we're wanting to find JK, I'm going to have to plug that in right here. So the length of JK is going to be 2 times 4 minus 1, 2 times 4 is 8. 8 minus 1 makes it 7. Okay, I want to show you why this works. I could also plug 4 in here. 3 times 4 is 12. 12 minus 5 is 7. And then 3 times 4 is 12. 12 plus 2 is 14. So actually, J would be a midpoint. I could prove that because this side is 7, this side is 7, which splits it in half, and 7 plus 7 makes 14. So it all checks out.